Hello everyone, welcome to a new session. A little refresh about lens formula and Cartesian sign convention which we have discussed in the previous session. According to lens formula is given by the expression 1 by f is equal to 1 by v minus 1 by u. As you know, lens formula gives us the relationship between focal length, image distance and object distance. It helps us to calculate the focal length, image distance and object distance using a lens, concave lens or convex lens. And according to the sign convention, Cartesian sign convention, a lens is placed at the origin such that any distances measured to the right of the origin is taken as positive, any distances measured to the left of the origin is taken as negative, any distances measured above the principal axis is taken as positive, any distances measured below the principal axis is taken as negative. We have already studied. So in solving numericals, the known values are substituted with the proper sign and we obtain the unknown quantity with its own proper sign. According to sign convention, as you know, in case of a convex lens, f is always positive, u is always negative, and v is positive for real and inverted images, and v can be negative for virtual and erect images. Okay, in case of a concave lens, u, v and f, all these have negative values, and the value of u is always greater than v in case of a concave lens, because concave lens forms always virtual, erect and diminished image. Okay. Now if you look at this lens formula, 1 by f is equal to 1 by v minus 1 by u, this lens formula doesn't give us an idea about the nature of the image or the size of the image. We want to find out the nature of the image and size of the image. Then how can we find out the nature of the image or the size of the image? Then there comes another quantity known as linear magnification. Let us see what is linear magnification. So it is linear magnification. We call it as magnification represented by letter M. What is linear magnification? Linear magnification gives us an idea about up to what extent an image can be magnified or diminished with respect to the size of an object. So mathematically, it's a ratio between two quantities. Basically we are doing a comparison with the size of the image with respect to the size of the object. So mathematically saying, magnification is a ratio between size of the image or height of the image, I take it as hi upon ho, or the size of the object, or in terms of image distance and object distance, magnification m is equal to image distance upon object distance, v by u. So very important formula, a tiny little formula which gives us a lot of information about nature of the image and size of the image. So magnification is equal to height of the image or size of the image upon size of the object, hi upon ho, that's equal to v upon u. So basically it's a pure ratio, it's a numerical value. Magnification is a numerical value. You can see from this formula it has no unit, it is a numerical value. Clear? Okay. So what does this magnification tell us about? So magnification, linear magnification, the formula will be or the expression will be same for convex lens and concave lens. For convex lens, let us see, magnification m is equal to height of the image. Height of the image is taken as negative. Okay. H minus hi upon height of the object is taken as positive, ho, that's equal to v, image distance is minus v by the image distance is it is taken as plus v and object distance is minus u. So minus cancel, so we get it as m is equal to v upon u for a convex lens. Is it clear? Just we are applying the sign convention. Then what about concave lens? concave lens. So in case of concave lens, magnification is equal to m is equal to height of the image. Height of the image, it is virtual erect, it is positive hi upon ho. Ho is also positive, that's equal to image distance is negative and object distance is also negative. So minus minus cancel, here m is equal to hi upon ho, height of the image upon height of the object, that's equal to v by u. So basically the expression for magnification is same for convex lens and concave lens. Remember, m is equal to v by u. Clear? So ratio between height of the image or size of the image and size of the object, or the image distance upon object distance. Clear? Is it clear? Okay. Now, as I told you, linear magnification basically a number. It's a pure ratio without any unit. What does this number tell us about? Looking at this expression, if the value of m is greater than 1, if the value of m is greater than 1, image will be magnified. Image is magnified. Okay. If the value of m is equal to 1, image is same size of that of the object. Image is same size as that of the object, okay. If the numerical value of m is less than 1, image is diminished. Diminished means smaller than the size of the object. Magnified means greater than the size of the object, okay. So if you are getting the value of m is greater than 1, we conclude that image is magnified. If m is equal to 1, image is same size of that of the object. If m is less than 1, image is diminished. So all these cases are possible in case of a convex lens. In case of a convex lens, m can be greater than 1, m is equal to 1, m is less than 1, depending upon the position of the object, okay. Now in case of a concave lens, m will be always less than 1. M will be less than 1 in case of a concave lens, because image is virtual, erect and diminished. So this number, this numerical value gives us an idea about the size of the object, size of the image, whether the image is diminished, magnified or same size as that of the object. Clear? Okay. Now we do grow a little more greedy. You want to know about the nature of the image. We want the magnification formula to tell us about the nature of the image, whether it is real inverted or virtual erect. Let us see. Let us consider the magnification formula. M is equal to v by u. Let us apply the sign convention in case of a convex lens. In case of a convex lens, okay, m is equal to v by u. V is always positive for real image and u is negative. So we are getting the magnification value as minus v upon u. So we conclude that when the magnification is negative, we conclude that the image is real and inverted, okay. See, by looking at the value of magnification, if the value of magnification is negative, we conclude that the image is real and inverted. So in case of a convex lens, the convex lens can form real inverted as well as virtual erect image. So the value of m can be positive or negative in case of a convex lens. In case of a convex lens, the value of m can be positive or negative in case of a convex lens. Remember, because convex lens can form real inverted as well as virtual erect image, okay. Now let us check the case of concave lens. In case of concave lens, let us see the nature of image. If magnification is equal to v upon u, so the value of v is negative, the value of u is also negative in case of a concave lens. So minus minus cancel, we are getting it as v by u, positive. So the magnification value is positive. We conclude it is a concave lens. We conclude it is a concave lens and the image is virtual and erect. Okay. So if the magnification is positive, we conclude that the image is virtual and erect. What is the nature of the image when the magnification is positive? The image is virtual and erect. It is possible in case of a concave lens. So this magnification is a very little formula. It gives us an idea about size of the image and also it gives us an idea about the nature of the image, whether it is real or inverted. So in case of a convex lens, M can be positive or negative depending upon the position of the object, because convex lens can form real and inverted image or it can form virtual and erect image. In case of a concave lens, the magnification is always positive because it forms virtual and erect image. Clear? So this is all about linear magnification. This formula is important. Application of the formula always comes in board examinations. The concept of linear magnification is very important. Okay, things are clear to you? You got it? Now let us move on to some applications, because concept is vague or it is incomplete without applications. So let's do some applications of magnifications combined with the lens formula and Cartesian sign convention. An object is placed at a distance of 10 centimeter in front of a concave lens of focal length 10 centimeter. Find first the position of the image, second the size of the image in relation to the object. So an object is placed at a distance of 10 centimeter in front of a concave lens. So we have the case of a concave lens. The lens is concave lens. Okay. So the image object distance is 10 centimeter. So object distance is always negative in case of a concave lens. Apply the sign convention, -10. Okay. And whose focal length is 10 centimeter. The focal length is also given as 10 centimeter. You know the focal length of a concave lens is also negative. So mark it as negative, -10 centimeter. Okay. Now what you have to find out? We have to find out the position of the image applying lens formula. So according to lens formula, 1 by V minus 1 by U is equal to 1 by F. This is lens formula. The formula, always write the formula because formula carries mark. We want the image distance 1 by V is equal to 1 by F. If you take it to the transport to the next side, it becomes positive 1 by U. Clear? Now let us place the value in the given formula. So 1 by V is equal to 1 by F. What is the value of F here? -10. So write the values, given value with the proper sign, -10, plus 1 by U. What's the sign of U? -10. That is -10. That's equal to 2 by -10. So 1 by V is equal to, cancelling we get it as -1 by 5, or V is equal to -5 centimeter. So the value of V, image distance, comes out to be -5 centimeter. It means that the image is formed in front of the lens at a distance 5 centimeter. 5 centimeter in front of the lens, in front of the concave lens, because the value is coming minus. Okay, this is the case of concave lens. The image distance will be always negative. So the unknown value comes out to be with its proper sign. You can see -5. Clear? Okay. Now this is the first part. Second part, we have to calculate the size of the image in relation to the object. I mean the magnification. Okay. So from relation, we know the magnification M is equal to height of the image upon height of the object, that's equal to V upon U. All of you must remember this formula. Magnification is the ratio between image distance and object distance. So we have the image distance. What is the image distance with the proper sign? -5 divided by U with the proper sign -10. Cancels out, it comes out to be 1 by 2, that is equal to 0.5. It has no unit since it is a pure ratio. So the magnification is 0.5. What is What do you mean by magnification is 0.5 or 1 by 2? It means the size of the image is half of the size of the object. So it means that size of the image is half of the size of the object. Clear? So one more add-on questions. The value of magnification is positive. So we can conclude that about the nature of the image, it is virtual and erect. So for virtual erect image, magnification comes out to be positive. Though it is not in the question, we can predict the nature of image looking at the value of magnification. Is it clear to you? Application of lens formula? Great, fine. Let's do one more numerical for better understanding. A convex lens forms an erect and 3 times magnified image of an object placed at a distance 10 cm in front of it. Find first the position of the image, second the focal length of the lens. A convex lens. So this is the case of a convex lens. Okay, convex lens. All of you write it. Convex lens. No problem. We can write it. Convex lens forms an erect and 3 times magnified image of an object. Read the question thoroughly. Understand it. It forms an erect and 3 times magnified image of the size of the object. 3 times more. So what is the value of magnification? So I can write magnification is 3 times 3. It is positive because the image is always, it is erect. For erect image, the magnification is positive. So m is equal to plus 3. We can definitely write. Okay, placed 3 times magnified image of an object placed at a distance of 10 cm in front of it. The value of u is 10 cm. The object distance, that is u is always negative. 10 cm minus 10 cm. Clear? Find the position of the image. You have to calculate position of the image. First part, position of the image. We know m is equal to v upon u. Okay, the value of m is given there, that is 3 is equal to v by u. Okay, 3 is equal to v by u, or v is equal to, I can write v is equal to 3u. The value of u is given there, place the value of u there. So v is equal to 3 into value of u minus 10, that is equal to minus 30 centimeter. So what is the value of image distance? Minus 30 centimeter. Thus image is formed at a distance 30 centimeter in front of the lens. In front of the lens, not behind the lens. Remember that in case of convex lens, so minus 30 centimeter is coming in front of the lens, same side as that of the object, at a distance 30 centimeter in front of the lens. Clear? Okay. Now steps are clear to you. So by applying the magnification formula, we calculated image distance where the image is located. Now second part, focal length of the lens. We have to calculate focal length of the lens. So we know the formula, 1 by f is equal to 1 by v minus 1 by u. Place the value over there. 1 by f is equal to 1 by v. What is the value of v? 1 by, put the proper sign, sign convention, place the value with the proper sign. Okay, so v minus 30 minus 1 by u. What is the value of u? Minus 10. Okay, that's equal to 1 by f is equal to minus 1 by 30, minus of minus, it becomes plus 1 by 10. Take out the LCM. 1 by f is equal to, LCM is 30 minus 1 plus 3 tens are 30, that's equal to minus 1 plus 3, that is equal to 2 by 30, that's equal to 1 by 15. So 1 by f is equal to 1 by 15, f comes out to be 15 centimeter. So the focal length is 15 centimeter. This is the case of a convex lens. Focal length is always positive. Clear? Steps are clear to you? You got the ideas? Now you know how to apply lens formula, Cartesian sign convention, and the formula of magnifications to find out the nature of the image and size of the image. Okay, thank you very much.